For this video, we're looking at the derivative of the natural logarithmic function. So I drew a sketch of a graph here. Would be like y equals the natural log of x. And if you take a look at the curve, you can see that it's very steep here. And the slope is also positive. In fact, it's positive the whole time. Over here, it gets shallower and shallower and shallower as you head to the right, so the slope is approaching zero. So if I were to draw the graph of the derivative, because this graph is going up the entire time it's increasing, then my entire graph would have to be in the first quadrant because it's positive. Now notice there is no graph to the left, so there will be no graph to the left on the derivative as well. You can only take the natural log of positive numbers. So my slope values are going to start very high positive numbers, so they're going to start up here. And then as we go to the right, it's leveling off, so the slope values are headed towards zero. They're not ever going to hit zero because this never actually levels off. It keeps going up forever. So a sketch of the derivative would look something like this. It stays in quadrant 1. The slope values start very high, and they're positive, and they end very low, but positive. So what this is a piece of your parent function y equals 1 over x. But our x value has to be greater than 0. So if I start with the natural log of x and I look at the derivative of the natural log of x, I'm going to get 1 over x. So that's what we have here. The derivative with respect to x of the natural log of x is 1 over x, where we understand that x has to be greater than 0. So if we do u substitution with this, the derivative with respect to x of the natural log of u will be 1 over u, but remember you have to multiply by a u prime. So it's very often simplified to u prime over u. Either one of these is correct. What if they're absolute values? Well, that actually doesn't change the value of the slope any, so it is also a 1 over u times u prime, or u prime over u. So I have four very basic examples of how you can use logarithms with your derivatives, or rather if you're taking a derivative where there's a logarithm in your problem. So we have 4 examples. And there's more than one way to accomplish some of these. This one right here, this is a u substitution problem. So my u equals 2x. So my u prime, or my du dx, equals 2. So if I'm taking the derivative of the natural log of u from the previous page, it's u prime over u. So u prime is 2 over u, 2x, and that reduces to a 1 over x. There's another way to look at this though. I can use my logarithmic properties. This is multiplication right here. That's the natural log of 2 times x. Well, I know that multiplication goes with addition with logarithms because we're talking about exponents really here. So the natural log of 2x equals the natural log of 2 plus the natural log of x. The natural log of 2 is just a number. So if I take the derivative of a number of a constant, I get 0, and then I know that the derivative of the natural log of x is 1 over x. So I would get the same answer either way I approach the problem. In this next example, this is u substitution. And to be clear, that's the only way to do this because you cannot distribute a logarithm over a plus or minus sign. You cannot do that. So this has to be u substitution. So u equals x squared plus 1. So my u prime will be 2x. So when I take the derivative of this, it's u prime over u, 2x over x squared plus 1. And that's your final answer. Notice that that actually can't be simplified anymore, so we are done there. For this third example, I have a natural log in the problem, but it's inside of my parentheses. So in this case, u equals my natural log of x. So my u prime will be 1 over x. So this is the derivative of u cubed. I'm taking it with respect to x. So I know that this equals 3u squared times du dx, or u prime. So putting my u and my u prime back in, this will be 3 times the natural log of x squared times 1 over x. And if we wrote that a little differently, this would be 3 natural log of x squared over x. Now, it's important to note that this 2 cannot be brought in front of the natural log. If it had been the natural log of x squared, this 2 could come down with our logarithmic properties, but that's not what this is saying. It's the entire natural log function being squared. It's only when an argument is squared that it can come in, so we are not doing that. For this problem, there are 2 different ways to do it. You can use u substitution, but if you do u sub right now, u has to be everything inside your logarithm. So we're talking x cubed minus 5x plus 2, but we're also including the square root, which means you have a u sub and a u sub. And this is one of the reasons why I like logarithms, because this is not your only choice. If you actually have a set of parentheses and something raised to a power, and this is raised to a power, it's a 1/2, then logarithmic properties do take care of that, because it's inside of our argument that the squaring or the square rooting or the power is happening. So I know that this is the same thing as the derivative with respect to x of the natural log of x cubed minus 5x plus 2 to the 1/2 power. Now, my argument is what's to the 1/2 power, so that's what I was talking about over here. It's the whole natural log squared, so I can't bring the 2 down. I can definitely bring the 1/2 down. So I'm taking the derivative with respect to x of 1/2 times the natural log of x cubed minus 5x plus 2. So now my u is a very simple u. U is x cubed minus 5x plus 2. And my u prime is the derivative of that, so 3x squared minus 5. So to write the answer, I know it's going to be u prime over u times 1/2. So I have a 1/2 times u prime is 3x squared minus 5 over u, which is x cubed minus 5x plus 2. And you can distribute this 2 in the denominator or leave it factored out, however you want to actually write that. And those are some simple examples. The next video will have some harder examples.